Hello and welcome, and this is going to be the fourth video of creating a weapon switching system, probably the last one. So the first thing I'm going to do is improve the holstered locomotion and make the camera follow the head plus an offset, which we'll set up when we are holstered. So to do that, firstly I'm going to go to the head rig and enable maintain offset and all axis constraint. Next I want to go to this and just put in the references correctly. There you are, the rig weight setter inside that script section. Now I'm going to create a new C# script, and this is going to be the spine constraint data. So in the spine constraint data, we'll have to use the animations of rigging so that we can define one of that. And it's a system serializable because we want to serialize this as a list in our player controller script. So firstly, we want to define this, which is the public multi-rotation constraint, rotation constraint. And I'll just rename that so that it's not specific to the spine only. Now we also want a range of 0 to 1, and this is the weight scale, meaning what's the max weight from 0, and that could be anywhere from 0 to 1, right? So that's what we want. It's more like a multiplier to the actual weight that we're going to try to assign to each of these on the list. Then we just need a bool whether we want to apply the weapons rotation offset on it or not. Next, we want a transform for the head transform in the camera section, and then a space, and we'll add the offset for the camera's head. The camera holder default offset, which is set to 0.25. Alright, so that should be the camera section. Then I'll just remove these older commented codes we wrote, and I'll comment this one out, this spine constraints, and make a new multi-rotation constraint data instead. And this is going to be our spine constraints from now. Actually, it's the multi-rotation constraint, again, not to be specific, because it can work on head as well, or any other rotation constraint, based on the type of multi-rotation constraint. So in the camera position annotation, we'll check if we're not holstered, then you'll perform the same code that we have written previously. But otherwise, we want to set the camera target position to the offset that we have, the default offset. But to calculate the default offset, we actually need to first calculate the head transform's position using this inverse transform point on the parent of the camera holder, adding the camera holder default offset at the end. That will give us a good local position. And then for the rotation, I just want to change that a bit so that it's based on the holstered. So if you're holstered, then only we want to actually, follow the X rotation. Otherwise, no. So, and in this one, we also need to check or holstered. So if you're reloading or we're holstered, we'll do this same thing that we're doing for reloading. All right. Now here we have an error, and we can fix all this actually by changing the code a bit. So firstly, again, we're gonna do the same spine rotation offset.y, and you want to assign this .y to the multiplication constraints at index 0 to that data instead. And then we do the for loop on the whole list, and the list at index I, you're going to have to assign the multiplication constraints offset rotation to the spine constraint offset at index I, and then we're going to calculate this based on whether they enabled apply weapon rotation offset or not. So if they did enable it, then you want to follow the spine rotation offset, otherwise we just want the vector 3.0. And then we have a float for the target weight, which is going to be a target offset y. Well, actually, the target weight is method.loop from the index and its weight, and then to, I think we can get to, actually we should just define it above here, I think. So float target weight, and we say if you're holstered, then it's 0, otherwise it's 1. It's the actual weight that we need to get, I guess, or the target weight. So the real weight that we're going to calculate now is the target weight times the multiplication at index y I dot weight scale. So this is going to give us the mapped value we're looking for. Then we want to assign the multiplication constraints weight to the real weight. That should work. So if you save and get out and let this compile again, we can give in the head itself, which is the mixamo rig, and then colon head, and we want to add 3 multiplication constraints. Actually, let me just get this to work properly by adding a space first, so that looks much better. Now, when I actually put this in the weapon section, or the look section, sorry, because this is based on the look, not on the clip rejection prevention system, it's in the look. So here, I'll add 4 of these constraints. First, I'll start with the first one, which is the spine precision constraint, and just to add them together. So as you can see, I'm going to set 1.3.3.3, and I'm going to give the correct head aim rig and spine 2 and spine 1, and then spine. And just disable the apply weapon rotation offset on the head aim rig. Alright, so now let's hit play and have a look. So you can see the spine rotation rig has 0.3 as the weight setup, and it's all working. They all have it down to 0 now, and the offsets are also working. So I think everything should work. And you can't actually change the head aim rig offset because it's being assigned to 0. And hopefully our camera also won't clip in the head, which was the reason I decided to use the head transforms position as the offset as well. So I think it works pretty fine. So here you have a haltered locomotion as well. So it's more like a first-person controller as well, without the weapon, just the weapon at the back. This is not being used, I guess. The spine. Let me have a look. So I think the spine rotation offset. It's not the spine constraint offset is not being used, I think. So I think we can just remove this maybe. Yeah. So just delete that out, and then remove a bit of commented old code. This one here. The toggle is aiming. This left hand IK and this one here, right here, then this code and this one as well. So we just removed a bit of redundant code. I mean, not redundant, just obsolete code, which we had commented out just in case. Now here I'm gonna add a new boolean underneath all the IDs. It's a bool to ask us if we can holster. So can we holster? That's the question. So actually here we had a lot of commented code. Let me just remove that as well. Now for the can holster, we can actually return using the can holster functions. Can perform holstering needs this to be enabled as well. Otherwise, it will not perform the holstering. The next thing we want to do is add a gunshot timer check for the switching system. So right, that's quite simple. Just come over here and add a new check for the perform switching, and that's it. And also for this one here. And that should pretty much be the reason I wanted to do that, because what if the weapon is shooting and during that you do this, you know? So now while I'm after my animation of the weapon's shot animation, then only I can switch. Now let's replace redundant code with better enemy events. Basically, what we've done here is a lot of repetitive code. And to clean this up, we need to find the duplicate code. Remember, I had mentioned it earlier that I've written a lot of duplicate code for the animation events right here, yes. So all of these functions, they do have a few specific reasons to be there, but we could actually convert these, most of these, into one function. So, this can be the old region. And the new one, first we want to have the snap current weapon to right hand and assign the IK targets. Not a very complicated function, just supposed to do a few lines of code. And here, basically, we will have to change the enemy events properly. Wait, just in case. Firstly, this is just going to call 2 functions. The move to right hand slot and the set all IK followers to target to targets. Then we need another function, snap current weapon to weapon slot, weapon gun slot actually. So it's the gun holder slot that we need to actually snap the weapon to next. Then actually the holster function, it wasn't really any duplicate code, I guess. It was pretty unique, so you just add the same code again based on the weapon type. And if it is a rifle, then we perform first we just want to snap weapon to available slot of 2, and based on the rifle slot 1 on the rifle slot 2. And that should actually do our job, I guess. Let me just create a switch between slots function, which takes in the slots, slot 1 and slot 2. Now what this one is going to do is check if the slot 1 has an object in slot. Does not have an object, then we can snap to socket our current weapon into it. And then we also want to equal it to a get weapon from slot, and the other slot because we're switching between the slots, so we do this as well. But if the other slot actually has an object, does not have an object, and the first one did have an object, then we want to snap to socket this one again, but this time in slot 2, and get the weapon from slot 1. Now I'm going to create the snap weapon to available slot of 2, and this function is going to take in slot 1 and slot 2. Then we'll do a switch. Actually, an if statement, just checking if slot 1 does not have an object, and then else if the slot 2 does not have an object. So if the first one does not have an object, we just want to snap to socket the weapon. That's it. And for the 2, just pretty similar to slot 2, just snap to weapon socket. Then we need a function which just returns us the weapon base from a slot, which is not very complicated. It just gets the index 1 of the object transform in the slot, and then just gets the component of type weapon base and returns that. We also need a snap weapon to slot based on pistol or melee type function, which takes in the weapon type. And basically, it's going to do a switch on the weapon type and check if it's a pistol. So if it's a pistol, we want to do pistol slot dot snap to socket, and we pass in the current weapon dot transform. But if it is a knife, then we do nothing right now. Actually, we need the references to the pistol slot and the melee slot as well. So we'll use the melee slot to snap socket the current weapon dot transform. All right. Alright, so whether it's a rifle or pistol, we do that using the case statement, and whether it's a pistol, knife also. So if it's a knife, then we just want to do snap up into a slot based on pistol or knife melee type. So the pistol, I was stacked it on top of the case of knife because how you do an OR statement in the case switch statements. So that's how you do this OR statement. Next, we have to make a function for switching the weapon. This one is going to start by setting the weapon data with passing this and false as the current weapon. Then we also need to get the weapon switch type, which is going to be an enum make. So public enum weapon switch type, and this enum is going to have all types of weapon switches we can perform. Switch between rifle, switch between pistol or knife, switch from pistol or knife to rifle, and then switch from rifle to pistol, switch from rifle to knife, and then let's go in. Alright, so we're just going to put the story type. Now here you go. Keep adding these. So all these statements now are available in the switch statement that I defined. Now if it's the switch between rifle, we're going to do switch between left slots. Just pass in the first slot and the second slot, and I think that should be it. Yes. Similarly for switch between pistol or knife, we're going to do switch between slots. Pass the pistol slot and melee slot. Then we want to similarly do the same thing. So for the from pistol or knife rifle, different function. Snap will install based on pistol melee type, and we'll pass in the weapon type and pistol slot and melee type. But then you also want to get the weapon from slot using that function by assigning it to the current weapon and passing the rifle slot 1, and that's going to give us the correct weapon hopefully. Alright, and then for the switch from rifle to pistol, now in this one, we snap the weapon to a available slot of 2 and pass in both the slots of the rifles. Next, we have the switch from rifle to knife, and this is rifle to knife, so first we need to snap to available slot of 2, and of course for the second last statement also need to get the weapon slot, so the final statement also get the slot after applying the code. Now let's fix this all, so I'm going to comment out all of these that are giving us errors. Alright, now what I'm going to do is I'm going to have a private void switch weapon. And this is going to actually accept our weapon type, the controller.weapon switch type, and it's going to be the weapon switch type. And we call the same function just passing in this thing. So our animation event is going to specify that through an enum. Alright, next we also need we need these utility functions, which are snap current weapon to slot, gun slot, and then just does that to the controller, and then snap current weapon to write an IK and assign targets. And that also calls the utility function there, which will do the job for us. Alright, so I'm gonna go to the holster. No, the holster function can stay the same. For the holster, we have the same function there, and the weapon switch complete also. We don't need to remove those. Now, for the pistol, we need 09. we should replace this by adding a new event. I'm going to use the switch weapon event, and I'm going to pass in the correct enum value. Secondly, for this one also, we want to now in this one use the snap counter weapon, pistol, or stuff that out. And then in last at the end, we want to also snap counter gun holder. So just do this for each and every one of these animations that I've got switch weapon placed by the actual argument, and then just gonna use the utility functions to perform those things that were being done continuously when we were using the repetitive code and direct functions using the steps. But now we have got much cleaner. All right. Okay, so we're gonna do for the switch from pistol to knife to rifle as well, and this one's gonna use the same snap current to weapon, snap weapon weapon to that. And the snap weapon, and then here we want to use the snap weapon to gun holder. Alright, then for the switch from rifle to knife, again we use our function and passing the switch from rifle to knife as the Next we want to call the third function as well at this point, and third function at this time. Next for the switch from rifle to pistol, we will again use the switch weapon function, but just change it to switch from rifle to pistol. Yes, so as you can see, using an enum and instead of having those model functions and putting each function into clean and neat, the repetitive code that was being done on every step 2 and step 3 on all the animation events. So it's much better to do it like this because we just reduced our code as well. So now this is all the old code, as you can see. The unholster function actually is much simpler. So what it does is it just does that. So yeah, okay. To move to the right hand slot and that. So here you go. That should do it for us. Now let's move on. So unholster rifle will do a similar thing. First it will snap with the right hand, and then it's just going to snap with the gun. And that should do it for us. So now let's give it a try. And as you can see, weapon switching is working as we expect it to work. I mean, it's a bit fast because my video is sped up, but what we can see here is a perfectly functional weapon switching system, which doesn't have any bugs at the moment. And actually, it's not found any. So this is the old code. We can just call this the enemy events obsolete backup, just in case we have some issues. We can look at that and use it. Now I'm gonna actually make this a new C# script by, well, there's no, I don't know how to do that, but anyway, I'm just gonna copy that, and I'm going to make that normal, and then I'm going to go here and create a new script and give it a name of weapon touch type. Then over here, I'm just gonna paste that in. All right. Now I'm going to, well, this is our public functions. Put them down at the bottom, underneath to make some sense. And these are all old events. We can comment them out. And this is the old backup. All right. Now let's save. Actually, this one is also supposed to be after that old code because we extracted it. I think that will be useful because yes, we never stopped using that one. Now let's go over the events and have a look at how it looks and remove each one of the old ones. Actually, I noticed that we just remove all of them except the weapon switch complete one and the other one, which is supposed to snap the gun holder. Snap the weapon to the gun holder. So it says to me the functions of support. That's because I mistakenly have commented out. I'll get that back in a while. Yeah. So let me fix that. You see the play model, I commented it out instead of extracting it and putting it as normal code. There we go. We shouldn't have any issues now. And here in the unholster function and unholster pistol knife. Now the others, and then move on to the next. Right, so the switch from rifle to pistol and the switch from rifle to knife, we're just going to look at these again. So it says to us the switch from rifle to knife is not supported. Yes, it isn't. Fix that actually, I forgot about it. Because I mistakenly removed the correct one. And here everything makes sense. Maybe not actually this. I've made a mistake. This one is supposed to be the snap count IKS. Let's see if this one works. Yes, so the old function. And this one also has an old function. I remove that. Yes, so this one doesn't have an issue. And then the old one is going to be this one, center. So let's switch between rifle You can see the switch weapon function is supposed to be kept, but the switch weapon can be discarded. And then at the end, we have a switch between rifle again. We can remove that. Now, switch between pistol and knife. All of that utility function that we had made originally can be removed. Alright, so we've now removed the elements that were no longer in use. Okay. And here we have the blend tree with all the IDs. Let's have a look at how it all works. So we can switch to our pistol as well. And so you can see the problem because the holster has no receiver. Yes, that's because I forgot to get that from back as well. Just like for the weapon switch complete. We'll fix that just right now. Probably gonna be in the play model as usual. I've just commented out so we can re-put it back and underneath the on weapon switch complete function. Now it's going to not show that problem of the function does not exist and our holstering should work. Let me give it a try. Yep. For not yet. Now, yes, it does work. Everything is working as we expected it to work. But this is not something you're looking for. The other weapon is getting activated. I mean, it's eventually coming up as if it should come up when it should not come up. So the reason is we need to also not be able to perform switching if you're holstered. So we need to unholster to be able to start switching, right? That makes sense. Alright, so now we don't have any weapon in the hand. And now we can unholster the weapon. Perfect. Everything does work as we expected it to. Now it doesn't provide that funny thing while weapons are only coming out. And we can switch to a knife. The knife isn't properly set up, but I'm gonna have to make a video on that as well. How to set up this basic knife. So next we need to look at the put enums in one strip. Basically, this is gonna neat up our enums cleanly. And we've got a lot of files which are just enums, and we could make just one class file. You can call it text file. All of the enums defined. That's much cleaner. So it's gonna keep a script for this enums. Delete everything in it. It's more like just a text file having all enums. So I'm gonna find public enum wherever it is. So all of the public enums, I'm gonna copy them and put them in the enums. There you go. Find type is already in there. The hand constraint type now. The matching type. And next we need the locomotion states. There you go. Air states. After the air state, I also want to put the weapon clipped state. After I put the air state. So aim state and air state. And now the weapon clipped state is going to be somewhere here. This one. The locomotion state, I forgot to remove. Actually, that's my backup script which has it. But we can ignore that, all of it. So I'm just going to get this one. There you go. I'm gonna actually have to remove the problems, so delete these files that I actually copied. Just delete all of those. Alright, so delete all the files one by one. And then in the enums, you can now see that you can also delete the old backup of the player model. And delete this one here as well. And then just going to say done to that task as well. Alright, I'll remove that job and save the class and back into Unity and wait for it to compile. And now the enums just has all the enums. Create a new folder for the enums and just drag that class in there. Alright, and now I close it out, save it out, and now we need to allow the weapon to change weapon icon, position, rotation, and size. Alright, so in the weapon SO, I'm just going to come over here and as you can see here, hide an inspector of vector 2 for the weapon UI position offset. the weapon UI rotation offset, which is also 0 by default. And then the size is already there, so we don't need to care about that yet. Just define these serialized properties here to be able to draw those in the inspector, the same name, and then just going to draw this after the icon image and I can hide in width. Here you go, put the name, and then put it over here as well. Now we need to draw them. Draw the property field. Alright, now let's save. Now let's see. So we've got these new vector 3s actually, when they should not be vector 3s. Next I will assign to the position offset and open to rotation offset like this. Anchored position and local rotation. Open image dot rect transform dot size delta. I'll assign it to new, actually not a new. We need a vector 2 for the weapon size, icon size, which is width of 0 by default. And we'll use that, and I'm just going to assign its x. I will assign its x to the icon image width, and for the y, I'll assign it to the icon image height. Alright, so after doing that, things should look better now. Just going to make a few nice comments to make this look much nicer. And close the player UI script. Now let's move on and hit play and have a look at how everything functions out. Here we have the knife, which, well, the camera positioning is not really okay for this one yet. But yes, that's because I've never changed that. And I can actually change the positions of this. And this will not do it in real time because it's event-based. So what I need to do instead is first get perfect position rotation, that I think is perfect, on the weapon icon itself. And then once I do that, I can just copy those values and put it inside. So let me just get the nice values that I think make sense. So that's the thing that I feel happy with. So just put those values so that the next time you might equip or change or whatever, whenever it's updated, it's going to update it to these values. For the rotation also at 90. Alright, so now if I come out of play mode. Alright, so that's going to be the end of this video. Just make sure to subscribe and get me to that 1 million target.